and get started on this here. Now we are starting on our trig functions. Now these functions here are basically one of the core functions of math in general, so they're very, very important. So let's go ahead and get started with them. There are 3 of them. So one of them is known as sine. Now it is spelled as S-I-N-E, but it is abbreviated with S-I-N, and this represents sine. The other one in this case would be known as cosine, and it is abbreviated with C-O-S. And the last one in this case would be tangent, which is abbreviated with T-A-N. Now, with these trig functions, whenever you're working with the triangle, you can actually find any missing side based on a given angle or based on 2 sides. So it all depends on what you're given. So depending on what you're given is how you can work with SOHCAHTOA. Now, SOHCAHTOA in this case is so. It's an abbreviation. SOHCAHTOA. And what this basically helps us is, depending on what side we're given, if we're either given the opposite, adjacent, or hypotenuse of a triangle, is how we can determine if we could either use a sine, a cosine, or a tangent. Now, so in this case represents, and I'm gonna go ahead and actually rewrite these vertically so I could. So in this case we have so, and we have ka, and then we have toa. And let me actually just move this a bit more up, or just this one. So let me just move it up here. So in this case, the S in so represents the sine. So we're going to be using sine. The O in this case would represent the opposite, and I'll go ahead and write opposite. The H would represent the hypotenuse, so hypotenuse. So based on a triangle, for example, if we're given the opposite side and the hypotenuse, then we're going to go ahead and use sine as our trig function. Now moving on to the next one, we have ka. Now ka in this case represents the cosine, so COS. The A in this case would represent the adjacent side, and the H once again would represent the hypotenuse. I wrote that wrong. So for example, if we have a triangle and we're given both the adjacent and the hypotenuse, then we know that we're gonna have to use the trig function cosine. Now the last one would be tangent, and we have tangent, T-A-N, and the O in this case is represented by opposite, and the A in this case is represented by adjacent. So for example, if in a triangle you're given both the opposite and the adjacent side, then you would have to use the tangent. So let's go ahead and move on to this section here. And this is what it looks like. So for example, if you're trying to find a certain angle, let's say you're given a certain angle A, then you would basically use the opposite over the hypotenuse in order for you to find one of the sides. And once again, this is based on the right triangle, so we could base it off this one here. So if we're given, for example, this opposite side and the hypotenuse, then we're going to have to use sine. So it all depends, and we'll go ahead and see that with the next examples that we see. And if we do cosine in this case, it would be adjacent over hypotenuse. And if we do tangent, it would be opposite over adjacent. And that's why we have the abbreviations of SOHCAHTOA. So that way you know that sine is opposite over adjacent, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we also have this here to explain. So once again, our acronym would be SO, which represents sine is opposite over adjacent, as you can see here. Ka, which is cosine, is adjacent over hypotenuse, and toa in this case is tangent, opposite over adjacent.